So let's look at this problem. We need to solve this equation. There are several options for where to begin on a problem like this. Do you guys have any ideas what you might like to do? Okay, so one option would be to simplify this side of the equation. So combine those fractions into one. And then once that's all simplified, put it together with the other side. The other option would be to, from the very beginning, try to get rid of all of our fractions. So, you guys like fractions or no? No? So let's try getting rid of it. Sound good? Alright. Alright, so when I look at this, I have this piece, I have this piece next. I'm going to make myself a note at the very beginning. What can x not be? It could be a -2, but in a fraction, what's the one thing that can happen? What's the one thing when you plug in your calculator, it says domain error? The bottom can't be 0 in a fraction. Can't divide by 0. Does 2 ever equal 0? No, because x minus 1 ever equals 0 when x is 1. So I'm going to make myself a note right now that x can't be 1. If I get that for my answer, I'm going to know that that's not really possible. If you don't write that down, that's okay, but you're just going to have to make sure you check your answers at the end of these questions. So let's look at the first. My denominator is 2. So if I wanted to get rid of that, you would have to multiply by 2. Does everybody agree there? If I take one thing times 2, though, I have to do it to every piece. So every single term. That would cancel those 2's, but we still have the others. My next denominator is x minus 1. So to cancel that, you have to multiply by x minus 1. But if you do it to one piece, you have to do it to all of them. So that would drop out the x minus 1. So what I have at this point, first one, my 2's dropped, so I'm left with a 2x minus 3 times the x minus 1. The second fraction, we had a 2x, we multiplied by a 2, and the x minus 1's canceled. And over here you had everything. You have an x, you have a 2, and you have an x minus 1. See how I got from the first to the second line. So just multiply by anything that shows up at the bottom. Now all we have to do is multiply this all out, and it's like a normal equation. So I'm going to start FOILing. So I'm going to get 2x squared minus 2x minus 3x plus 3. Would be 2x times x subtract 2x squared, what happens? Those cancel. So let's see if I add, I've got negative 5x plus 4x plus 3 equals a negative 2x. I add my x over. I get x to be. Is that an okay answer? The only rule I had was that x couldn't be 1. I did get 1, so it should work. Now, if you hadn't written down what x couldn't be, then you absolutely need to go back to the original problem, make sure negative 3 doesn't make your denominator 0. You also know on test or quiz, you could check this just by plugging negative 3 back into the original equation and making sure it works. Does everybody know how to check like that? What questions do you guys have right here? First, what can x not be on this problem? 5. Okay, so second, we really have 3 terms here. We have the first fraction, a 5, and the second fraction. What do we need to multiply by to cancel my first denominator? Right, that exact thing. Whatever it is, that's what you're multiplying by. So you have to take all 3 terms times an x minus 5. So those 2 would drop out. It also cancels those 2. Do we have anything left to cancel here? No, so that's all I have to multiply by. So the first one, I just have x. We have 5 times x minus 5. Over here we just have equals 5. Solve this equation. So 1x plus 5x is 6x. If I add my 25 over, we get 30. Divide by 6 and x equals 5. No problems with that? X can't be 5. So what do I write? No solution. This problem does not have an answer. Questions there? So let's do some more. So let's do one more together and then I'll let you guys try one. Sound good? What should we do here? How is this one different than the others? You want to make sure your denominators are factored first. I don't want to multiply by more stuff than I have to, because that gives me more complicated equations solved later on. So I'm going to go through and make sure every denominator is completely broken down. I can't do anything with x minus 2, so this first one is just going to stay. 1 over x, can't do anything with that. But what can you do with x squared minus 2x? Okay, I'm going to call it an x, and that would leave me with an x minus 2. So, let's go through. The first fraction, what do you need to multiply by? Okay, do that to all 3. So what happens is my x minus 2 drops here and over here. Now what am I going to do? We have an x for this one, so you're going to have to take everything times an x. So my x cancels on that term and on this one. I didn't write down what can x not be on this problem. The very first fraction couldn't be a 2. What about the second fraction? It was just x on the denominator. 0. Okay. So now we can solve this. So I'm left with a 3x plus 2 times x. A 1 times an x minus 2. Just a negative 2 over here. Plus 3x. If I add my 2 over, it's actually drop. What are you going to do with that? Okay. And then negative 2 plus 2 is 0. You could do the quadratic formula and solve it, and that works. What else could we do? Just factor out an x, or even a 3x. If we do that, you're left with x plus 1. Okay, what would make this first term equal 0? It's just x equals 0. And then what would make x plus 1 equal 0, and that's negative 1. Any issues with that? Right, we said at the beginning x couldn't be 0 or 2, so 0 does not work. And negative 1 is my only solution. Always check those answers. Here's your problem. And I'll walk around and answer questions. Can't be reduced. So I just have negative 4x over x minus 1. Positive 4 over x plus 1. But difference of squares, that's like a quadratic. You could think of it as what multiplies to negative 1 and adds to 0. That would be positive 1 and negative 1. So right now, what can x not equal? Plus or minus 1 negative. Okay. First fraction has x minus 1. So I'm going to take everything times x minus 1. So I know those cancel and these cancel. Second fraction has x plus 1. So you also have to multiply by x plus 1. I saw a few people that forgot to put the x plus 1 on the first term. Whatever you do to 1, you have to do to all 3. So those drop and those drop. My fractions are all gone now. So what I am left with is negative 4x times the x plus 1, 4 plus times the x minus 1 and negative 8 all by itself. So that gives me negative 4x squared minus 4x plus 4x minus 4 equals negative 8. And those would drop. So what did you guys do? Did you set it equal to 0 or did you move the constants to the other side? Okay, Quentin, you set yours to 0. I'm going to do what you did then. So then you can divide by negative 4, so x squared equals 1. So if you add a square root and a plus or minus, you get x to be plus and minus 1. Can't happen. Okay, where did I lose you?
So after like you put like, where did you get the negative to go to the other side?
Right from this term, when I took 4 times the x minus 1, so that would give you 4x minus 4. Other questions? In walking around, you guys have the process, but your work's a little sloppy and you're losing terms, so just try to clean it up a little bit so you can make sure you're keeping track of your terms. I'm going to start the next type of equation today and then give you guys a little bit of time to work so you can ask questions if you need to. Okay? We're going to pick up with more radical equations tomorrow. So we're just starting them right now. Let's say I asked you to find solutions to this. When you solve a radical equation, the very first step is to isolate the radical part. So I need this radical by itself. How would I do that? Add our 2. So then we have the cube root of 2x minus 4 equals 2. Now, we have to take each side to a power to cancel the radical. So what would be the opposite of a cube root? To cube it, yeah, just cube each side. So a cube and a cube root would cancel and just leave you with 2x minus 4. Over here, 2 to the third is 8. Now we can solve that, can't we? So if we add our 4, divide by 2, and we get x equals 6. Now I want you to get in the habit of always checking these answers. It doesn't happen with odd roots, but when you have even roots and you start squaring and taking things to the 4th power, sometimes you get answers that don't really work. So just in general, if you have a radical problem, always check at the end. If I put a 6 in, then I've got 12, minus 4 is 8, cube root of 8 is 2, minus 2 is 0. So it does work. You don't really have to show me the work that you check, but you do want to make sure you're doing that. Last example for the day. First step, isolate the radical, but it's by itself. Now we have to cancel it. What is the opposite of a square root? Square. When you do power, you are taking it to each side. So I'm not squaring each term, I'm doing each side of the equation. So those cancel. But over here I'm left with x minus 7 squared. What does that mean? You have to write it twice and FOIL it. So that gives me x squared minus 7x and minus 7x would be negative 14x plus 40. Are you guys okay with my foiling if I start combining those middle terms as I go? I didn't lose anybody. It's a quadratic, so set it equal to 0. So I have to subtract my x and add my 1. Factor. So x squared breaks into x and x. What multiplies to 50 and adds to negative 50? Negative 10, negative 5. So x equals positive 10 and positive 5. But what should we be doing now? Check. You always want to go back to the original when you check. So, like to check x equals 10, if I plug that in, I get square root of 9, which is 3, 10 minus 7 is 3, so that one's fine. If you check 5, 5 minus 1 is 4, square root of 4 is 2, 5 minus 7 is negative 2. That one does not work. So x equals 10 is actually the only answer because the 5 did not check. Any questions? So I want to give you guys some time. We actually have like quite a bit of time to get it out here at 10:36, so you've got about 15 minutes. It's actually not that many problems. My EOO means every other odd. So that'd be like, you do problem 7, skip 9, do 11, skip 13, do 15, 19, and 23 if you prefer to write it out. So it's actually only 9 total problems here. I gave you all odd problems because I want you to be checking these as you go. Answers are in the back of the book. So if you just turn in homework tomorrow with answers and no work, I'm not giving you any credit.